Sponsored by Picastro. It's like Instagram for space nerds. Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Hope you're all well. If this is your first time here, we hope you'll all stick around and see what it's all about. So, welcome to Mars Month on Space Oddities. As you might be aware, all throughout September, we're going to be posting videos and live streams all to do with the planet Mars. And to that end, I'm delighted to welcome our special guest for this evening, Mr. Nicholas Booth. Should we address you as Nick, sir, or Nicholas?
Yeah, Nick's fine. Nick's fine.
Nick's fine. Okay, well, welcome to Space Oddities, Nick. And a little later, we're going to be discussing the search for life on Mars with Nick. So we look forward to that. Got the usual suspects with me this evening, Daz, Michael, and Roger. All right, guys?
Hi, guys.
Lovely to see you all.
Hi, thank you.
Lou hopes to be joining us a bit later, but for now, it's just us. So we all hope you all had a good week. We certainly have been busy getting Mars Month ready. We've already got a couple of videos up on the channel, and there will be more going up each day this week as of tomorrow till Sunday, and then next week we'll post some more. Patreon members have already got all of those videos for this week available. They will be in the usual place. So why not join our Patreon page, and you get all these lovely perks, as well as all the presentations that we deliver in the live streams. Videos as well, and some other stuff. And as a present for joining, we have a little present for you. We are going to send you two 10x8 astro prints taken by astro photographers from Space Oddities, and lovely they are too. So for a very reasonable monthly fee, you can join the Patreon, support the channel, which is what it's all about, because we need your money. And it's a frank admission, but we do, because without money, we can't keep the channel going. So if you'd like to support Space Oddities, head over to patreon.com/Space Oddities and join up. And you get all these wonderful member bonuses. There's also lots of different chats there where you can chat with other members, you can chat with us. And we're trying to build a little bit of a community there on Patreon. So do come along and join us. And we hope you do and you enjoy it. Okay, what have we got this evening? Apart from our chat with Nick a bit later, to kick off Mars Month, we've got a presentation called Mars 101, the basic facts about Mars. I thought that might be nice to do just to set us off on the right foot. Everything you need to know about Mars, all the basic facts. So we got that coming up later. We've also got our regular features, of course. We've got Constellation of the Week. We've got Einstein of the Week. We've got Roger's Night Sky Guide and the Gallery. And news of a rather special event, an astronomical event coming up on Sunday, but I'll let Roger tell you all about that. If you would like to support the channel in other ways, don't forget that you can, of course, buy us a coffee, because astronomers' lives matter. And if you scan the QR code or click the link that's just appeared in the chat, then you can go to the Buy Us a Coffee page and buy us a coffee. You can also, of course, click the super chat icon, which is the one with the $sign on underneath the chat window, to make a donation directly to us. Of course, you can also head over to the Space Oddities shop, where you can buy your lovely Space Oddities merchandise, consisting of t-shirts and hoodies. We've got some lovely stuff there for you. Let me just put that up on the screen. It doesn't appear to want to stay there. There we are. So you can scan the QR code, or you can click the link again that's just appeared in the chat to buy your lovely Space Oddities merchandise at the Space Oddities shop. Don't forget the Space Oddities website as well, which is https://spaceoddities.space, where you'll find lots of lovely stuff, and also all of the images that have been submitted by our viewers to Gallery of the Week. Each submitter, if you like, has their own gallery on the website. So that's really lovely to look at, all the photos, all the details, how they were taken, etc., etc. So we hope you'll stick with us for Mars Month. We've got lots of lovely stuff coming up. As you know, we did Moon Month in April, which was a big success, and everybody seemed to really enjoy it. So we're hoping that that Mars Month emulates the success of that to a fine degree. So do keep your eye on the channel. Don't forget, if you're not subscribed, why the hell not? Subscribe now, click the notification icon, and you'll get to know when we're posting new stuff on the channel. So that particularly for Mars Month, you don't miss out. I think that's all the housekeeping out of the way. We hope you've all had a great week, viewers. I'm just going to have a quick look in the chat, see who's around. Who have we got? Right, Carl's there. Hi, Carl. Hope you're well. Anybody else want to say hi?
Deep Burrito,
Right.
Alan, Stuart.
Oh, right. Why am I not seeing those?
If you just switch your chat, that's all you'll see.
Yeah.
When you just switch it on. But yeah, they're all the usual suspects are here.
All the usual suspects. Great to see you guys. Thank you so much for being here. And I hope you're looking forward to Mars Month as much as we are. So let's kick things off tonight, as we always do, with the news. Not that much of note in the news this week, but I've got a few stories for you, which I hope you'll enjoy. And let's crack on with the news. So, what have we got in the news? Well, the first story of the week, of course, was the flight by SpaceX, the Starship Flight Test 10, which was a, forgive the pun, a roaring success. And the mission, after the previous 3 failures, succeeded in all its ambitions. Starship launched with a Super Heavy booster, separated, went into its suborbital ballistic trajectory. They tested the release of 8 dummy Starlink satellites, which went perfectly. And then they did a Raptor relight, a crucial test of a Raptor relight in orbit, or in the suborbital trajectory, should I say. And eventually the booster came down in the Gulf of Mexico. They weren't going to catch it with the chopsticks this time around, because they were doing a simulation of a Raptor failure and substitution during the final phase of the descent. So it splashed down in the Gulf of Mexico and fell over and exploded. But that was expected, because it's what happens when red hot engines meet cold ocean water. All the fuel lines fracture, and boom. The Starship came down in the Indian Ocean, and we can actually see that happening. Here we go. It looked like something out of sci-fi, but no, here it is again in slow motion. And the precision of this landing was incredible. It came down, they estimated, only about 3 meters from its projected landing spot, right next to the remote buoy that was filming it. An amazing descent. Now, if you're wondering why the spaceship went up black and silver and came back red and white, it's because SpaceX were testing some new metallic heat tiles, which they think may replace the actual ceramic heat tiles that they're currently using. And they oxidized during the flight. The metal oxidized, which meant that we had this red color spread all over the spacecraft. The white of the nose cone was because that was an area where SpaceX had intentionally removed some of the heat shield, some of the tiles, to see what would happen, basically. And that caused the underlying insulating blanket to show through, which was the white color. So big success for SpaceX. They've broken the run of failures. The next launch, they're saying, will be around the end of September, so not too long to wait. I suspect they'll be trying the same flight profile. They've got to prove they can do it reliably more than once. And there will obviously be modifications to both the booster and the Starship as a result of getting that priceless telemetry from both of it. They'll be able to make some modifications and improve things. So, moving on to the next story. This is all about JUICE. That is to say, the Jupiter Icy Moons Explorer, which Europe has launched towards the Jovian system to explore 3 of the moons of Jupiter, but particularly Europa. And a couple of days ago, it did a flyby of Venus. Now, they were a little worried because last month they lost contact with the spacecraft altogether, and for a while, but they managed to wrest control back. They think that was being caused by some sort of antenna misalignment, but they're not quite sure. Anyway, JUICE completed the Venus flyby to accelerate it on its course to Jupiter, which it's going to reach in 2031. If you're wondering where the photos of the Venus flyby are, there weren't any. They didn't take any photos. And the reason for that is the spacecraft came so close to Venus, it was actually too hot to switch the camera on. They didn't want to damage the camera. So on this occasion, no lovely photographs of the Venus flyby, unfortunately. But well done to ESA. JUICE is now completely on track. I think it's got one, I can't remember, but I think it's got one more flyby of the Earth and another one of Venus before it finally heads out to Jupiter, just to give it enough velocity. So there we are, successful Venus flyby. And the other story this week is we finally got the much awaited data about Comet 3I Atlas from the James Webb Space Telescope. The data was acquired a couple of weeks ago, so obviously the comet was further away then. But for proprietary reasons, it was delayed being released to the public. But I can now reveal exactly what the James Webb Space Telescope has found out about this really interesting and different interstellar comet. So the first thing is that it looked at the composition of the comet. They found that it's dominated by carbon dioxide. The coma is strongly dominated by carbon dioxide. In fact, the ratio to water is approximately 8.1. This is one of the highest ever recorded in any comet. Now, what this means basically is it's telling us a story about the origin of the comet, which we don't quite understand yet. Hopefully we will in time. So this value is 6.1 standard deviations above the typical trend for other comets. So the comet is far more dominated by carbon dioxide than other comets that we've seen. Also, hang on. Right. The presence of other volatiles in addition to water. Now, they detected a lot of water coming off the comet, but this is not coming from the nucleus. This is actually being generated in the coma, they think, from sublimating ice grains in the coma. But the actual amount of water on the comet is actually quite low. But they've also detected carbon monoxide and carbonyl sulfide, along with the dust and water ice, especially on the sunward side. And this mixture of carbon monoxide to water is about normal. It's about what we see in solar system comets. So that wasn't really a surprise. The JWSTs also detected isotopic signatures indicating a similar rate of carbon-12 to carbon-13 as found on the Earth. So the carbon isotopes are about what we've found on the Earth, nothing too unusual there. But this exceptionally high CO2 content suggests a few possible origins for the comet. It may have formed near the CO2 ice line of its parent protoplanetary disk, where carbon dioxide easily freezes, or perhaps it's been exposed to intense radiation somewhere in its long journey around the galaxy. Don't forget that some estimates of the age of this comet have put it somewhere maybe about a couple of billion years older than the Earth. So this may prove to be an exceptionally old body. And the other possibility is that in its travels being subjected to radiation from stars, and we've no idea where this comet has been in its journey around the galaxy, but it may have been subjected to so much ultraviolet radiation that it's developed a thick insulating crust. And what this means is that the water expression by the comet is being subjugated, which it may explain its low water content. Anyway, those are the key findings of the JWST as regards the comet. Really interesting stuff. There will be more data. we're hoping that the Juno probe, which is, as you know, orbiting Jupiter, we'll get a closer look at the comet. It was suggested that Juno actually goes out to meet the comet, but NASA said it hasn't got the fuel and the trajectory is not right, and Juno is going to stay in orbit around Jupiter, but it will actually get a lot closer to the comet than the Earth will. So we look forward to much more data about the comet. The comet reaches perihelion, that is its closest point to the sun, on October the 27th, if I remember rightly. So at that time, unfortunately, it will be on the far side of the sun from the Earth. So we won't see it when it's at its closest approach, which is a bit of a shame. But of course, that does indicate that all this ridiculous nonsense that's flying about on the internet about the comet being an alien spacecraft. Well, if it's an alien spacecraft, they didn't get the trajectory right, because it's going to be on the far side of the sun to us. Of course, there are conspiracy theories going around that NASA's already launched a probe to the comet. They found out that it's a spacecraft that's full of aliens, and they've sent people out to meet it, and you know, the normal guff that goes around the internet. Anyway, so that's the news for this evening, and hope you enjoyed that. More next week, of course. Interesting stuff. We at Space Oddities were so glad when Starship flew, because we'd had 2 late nights before that, with 2 scrub launches 2 nights before that. So when it did happen on the 3rd night, we all breathed a sigh of relief, especially me, because I'm an hour ahead of the guys in the UK. So I had a very late night, but it was a great flight. Guys, any last thoughts about the Starship flight?
Well, I thought it was absolutely fantastic. I mean, it was nail biting all the way through.
Yeah.
And what struck me was also when they did the Pez dispenser. Oh, hi, Rachel.
Yeah.
Yeah, when they did the Pez dispenser, which was really fascinating to watch, seeing all the mechanisms and the chains and the cogs all turning, just shoving those little dummy satellites out. That was very interesting. But as I said, it was nail biting all the way down to the splashdown, because it didn't go, all the way to pan, because we had that big percussive sort of, like, not explosion, but something failed on the engine bay, which made concern about the where the actual engine's damaged. But everything worked fine, and it's a major step in the right direction. But there is still quite a bit of work to do. So, but yeah, it's in the right direction.
It was although it was nail biting, it was a highly enjoyable flight, wasn't it?
Yeah. Yeah.
It was fantastic. I mean, it looked like it was something out of science fiction. It really did, especially that landing. That landing was amazing. So there we are. I'd like to welcome Rachel tonight. Lovely to see you, Rachel.
Hi,
Good
Rachel.
evening. Sorry I'm late.
That's all right. No problem at all. Got a quick question from Derek. No, that's the answer, not the question. Let's try. I know what a question is. I know what a question is. Can Atlas be intercepted, or is that too late to get a sample? No, it's far too late to launch the spacecraft, Derek, I'm afraid. This comet kind of snuck up on us. We didn't realize it was there until it was fairly well into the solar system. So it's far too late to launch anything, unfortunately. So Sandra Gray says it was fantastic. Yes, it was a fantastic flight from Starship. I assume that's what you're referring to. We look forward to the next one. Last week of September, first week of October. We will, of course, keep you posted. But it was absolutely amazing. The best thing is that SpaceX have broken their run of bad luck and proved they have a reusable vehicle. We've got one more flight left with the Block 2 Starship, and then they completely changed the design and upgrade it to Block 3. So we'll see what happens with the Block 3, because the Block 3 testing has not gone well. They've lost 3 of them. So we'll see what happens. Anyway, the Deep Burrito says the pod bay door opening was cool. Yes, it was.
Yeah.
Yeah, the Deep Burrito. I mean, I'm sure you breathed a sigh of relief as we did when that door opened, but more importantly, when it closed again, because the closing was the essential bit. Because if it hadn't closed, they couldn't have re-entered, basically.
Oh, true.
Without losing the ship. So there we are. Anyway, let's move on. Let's get Michael to introduce our guest for this evening. Michael, over to you.
Hi there. Right. Yes, tonight I'd like to introduce Nick Booth, author extraordinaire of a book, The Search of Life for Mars, which came out a few years ago. Co-authored, I should say, I believe. I met Nick way back in 2003 when the space shuttle was going to do the first servicing mission for the Hubble Space Telescope. And we were part of the international media contingent for that flight. I managed to get a pass for that myself, so I was quite pleased about that. That's another story. And Nick, I'd like to ask you about your experience writing the book, your journalistic history as well. Maybe you can talk about that.
Absolutely fine. And also, which I didn't think I was going to do, there'll be one plug. That's the book.
Yes.
I'm quite happy to sign that and make it as a raffle prize for anybody who.
Oh, thank you.
Thank you very much.
That's very kind.
Yeah, my pleasure. So yeah, I met. It was actually 1993 because it makes us even older.
Sorry, 1993. You've got something wrong there.
Yeah, that's all right. We don't need to be reminded.
It's his age.
It's my age.
Yeah.
32 years ago.
Yeah, exactly.
Wow.
We all had grey. We all had dark hair.
Yeah. Yeah.
But that was that. Well, I love doing these things because I was a teenage astronomy nut, and I was a teenage. Used to go to the local astronomical society in Cheshire, so we used to go to Stoke-on-Trent, and by a happy accident, my mum worked for the council, and a guy who worked there was a guy called Paul Doherty, who was assistant director of the Saturn section of the British Astronomical Association, and he had I think it was an 18-inch telescope in his garden, an observatory. So it was like, wow. And it was through Paul that I met John Mason and Patrick Moore and a guy called Ron Madison who died. And then my first job was on Astronomy Now magazine. So, that makes me even older. My first job was when I was 23, and I got that job, and it was only part-time because the magazine was only starting, and they did a trial run of a few monthly issues. And I was also then doing a book about Mars. So I've half written 2 books on Mars, which makes me a kind of author of one book, I guess. And that was, excuse me, in 1987. And so from 1987 onwards, I was in a pretty good position as a hack to go and cover this stuff and talk to the famous names. My teenage years, I'd also managed to persuade the Jet Propulsion Laboratory to give me a summer job, which I could tell, that's another evening's talk. So I went to college and thought, I was going to go off and be an astronomer, and I just wasn't numerate enough. I just wasn't good at maths. So they always say, if you can't do something, teach, which really annoys me, and I'm sure annoys Rachel as a teacher. What if you can't do anything, be a writer instead, because it really is the last resort of the scoundrel. So I was in a lucky position that on Astronomy Now, freelancing the newspapers. When I met Mike, I was freelancing. It was there for the Observer and the Times, and then the late 90s, I was a technology editor on the Times, and I've been gone from newspapers now 25 years. But I kept all my notes, so that's the reason why I can bore you senseless tonight about Mars, because I've met most of the people who'd been involved in these missions, and some of them I'd even got to know really quite well, because I used to, when I was on the Times, it was the technology section, so all the various IT companies would fly us to California, in which I had no interest, apart from what's your name, what do you do, and all that. And then I'd go down to JPL, talk to people there. And near to Silicon Valley is the NASA Ames Research Center, and so it was a good position to be in. And I taped most of the interviews because not that any of them were that earth shattering in the sense, but I'd got them. So when I decided to revamp the notes and work with Elizabeth, a Canadian science writer, and in a local DJ kind of link. Hi Lou, you're in Canada, aren't you?
A little south.
A little south. Okay.
I'm in Maryland.
Oh, you're in Maryland. Sorry, for some reason I thought you were in Canada. Should we start this again?
Nobody
Take two. Yeah. So Elizabeth, who I did the book with, because I stopped being a reporter in '99 and didn't really cover it. Stuff would pop up and I would see things, and then suddenly Mars got. I got back into it because the thing that got me started was Mars. And as I've always said, if you did a diagram, there's Venus, and my interest is here, Mars, then after Mars it drops again. It's just. I was 12 when Viking landed, so the first landings on Mars were when I was 12, which is absolutely the perfect age to get excited about something.
Yeah, sure.
Yeah.
I was 18. God, that's terrible.
Yeah. Yeah. So, So, anyone else want to ask Nick anything about?
Yeah. So the search for life on Mars, Nick, it's been going on for a long time now.
Yeah.
What's your own personal feeling? Do you think that we will ever find either current or past life on Mars? Do you think it's actually there?
Yes, I do. And I think the story is the best way is imagine somebody with letting go of something that comes towards you and then it comes back. And it goes. And that's the story of our interest in life on Mars. The dawn of the space age, it was thought there probably would be something. There'd probably be bacterial type life. There'd been observations in the 50s of, I'm trying to remember the exact, the spectra of it was interpreted as chlorophyll. And if you had chlorophyll, that suggested it would be plants. But in those days, it was ancient technology that you were on the margin, and it was the way you interpreted it. And nobody was actually quite sure. But there were a couple of people. There was a guy at Harvard, William Sinton, who'd observed what he said was chlorophyll. So it suddenly, the only way you're going to go is if you go there. And Mars was thought it was going to be, well, let's do it. So what we need to do is get the best view that we can with the technology of the time. So the first two American missions, Mariner 3 and Mariner 4, I was born in 1964. So in November of that year, they were launched, and it was still the very early days, and it was the Wild West because the technology was very, it either worked or it didn't, and anything that went wrong always went wrong at the worst possible time. So Mariner 3 takes off on, it was November the 5th, and it got to the top of the atmosphere, and unfortunately, the fairing cone didn't deploy. So you'd got Mariner 3 trying to open, and it's like imagine trapped blue bottle at the top, and it didn't get out because it couldn't, it didn't get its solar panels. They redesigned that in 3 weeks, which I always thought was quite amazing that they could actually redesign. Yeah. And then at the end of that launch window, so again, I should explain, you can't see Mars and go, I'm going to go. You've got to wait for the barest minimum energy that you can use to get there, and these long transfer orbits. And it opens and then it closes, and the best time to go is usually bang in the middle. So they did Mariner 3 at the beginning. There was a problem, and they gave them enough time. November the 28th, off it went, and exactly the same. Well, it separated so there was the Atlas Agena. The Agena on the top of the thing was originally a military type missile. So it then opened, flew off. And Mariner 4 had to orientate by a sun sensor, which is quite simple. And then Canopus, which is not the brightest, that's Sirius, obviously, one of the brightest stars in the Southern Hemisphere.
Yeah.
And they found Canopus, and then they lost it. And looking at and I talked to the guys, I said, well, what was it like? And they said, well, you were looking, and the spacecraft was because what they'd not factored in was that paint had come off the Agena stage, and it was floating around. So the paint is floating around and catching sunlight. So this thing is like, oh, there it is. No, it's there. Oh, and all that. And then they had about, I think it was 10 hours to do it. They got it to calm down and they fired the engine. So you need to know exactly where you're going. So you've got the sun, Canopus, so you're going to go in that direction and not, back to the Earth. They lost Canopus about, I think it was 2 hours later, and they didn't know, so it was on its way. Halfway to Mars, one of the instruments just packed up. It just suddenly stopped sending data. It was the solar wind instrument, And then by the time it got to Mars, it switched itself back on again. And to me, when I was a kid, it was people said, well, these unmanned probes, as they were known then, they're not as interesting as the astronauts. And I've always thought that was nonsense, because the stories behind the scenes, just to get these bits of recalcitrant machinery to work. On the way to Mars, and then they suddenly noticed at Mars, some radio telescopes noted a lot of noise, and they thought, holy, moly, there's like some sort of activity, which they thought if that's to do with Mars, by the time the spacecraft gets there, they'll run out of, the energy would be so much it would affect all the instruments, and the computer would probably be fried. It turned out that what happened was it was a gamma ray source that nobody had seen before that was directly behind Mars. So when Mars moved in its orbit, it was it was. All these missions in the early days were like the Wild West. We don't know if we're going to get to the homestead because there's all this stuff going on. It gets to Mars. Everything was done by, it was 20 minutes away in light minutes, so it's 20 minutes, so it had to be scheduled. And there was a tape recorder, which literally was an ancient tape recorder, and it recorded all the observations. And then the data came back that seemed to suggest that the tape had carried on spooling. So in other words, you spent all this money and all this time to get to Mars, you recorded this data, and the bloody tapes carried on. Anyway, it turned out it was an error in the. So the whole thing was like this, that in those days. And what happened was that in the press room, there was almost a riot, because the press, understandably, said, we want to see the pictures. And it was like, well, hold on a minute.
Sure.
We were only transmitting at 8 bits a second, so it took 10 days for all this data to come back, assembled to do, and then there were the photographs, and there were 21 photographs, and I think it was photograph number 11 was a shock, because there was a crater. Literally the last thing that people thought that you would find on Mars, because they thought there'd be no craters because there's an atmosphere, there's probably geology that's got rid of all this stuff as on the Earth. They weren't expecting Mars to be moon-like, if you like. And that was when this pendulum that was building up towards we're going to find this stuff came back, because suddenly Mars looked dead, and it looked ancient, and there didn't seem to be. Again, another thing that happened in those early years was they'd managed to pick, because they didn't know whether they wanted to get just high resolution images of one area, which would be symbolic for the rest of the planet, and they managed by complete fluke to pick probably the most boring part of the planet. So it was, it's a great story, again, in the book, but it's a great story anyway. There's some great JPL footage. There's a thing, the original film was called Mars and the Mind of Man or something, and more recently the JPL, and you just watch all this happening, and it's just absolute. They had cameras and they filmed all the guys, and you see them there going, oh my god, the tape recorder and all this sort of stuff, and that to me was what it was all about.
Yeah.
So that was Mars in 1965, and then after that, there was a big mission that had been planned, which was called Voyager, the original Voyager, not the one that went to the outer planets, and that caused conniptions because the other part of NASA, the astronaut bit, they were building Saturn V's to go to the moon, and George Miller, who was head of that side, said to his equivalent on the planetary side, "Would you like one of these?" Because they didn't know how many they were going to. I don't know how many attempts it would take to get to the moon, so they got a production line, and they said, "Well, we've got a spare one. Do you want to use it to go to Mars?" And it literally was like that, and it was the planetary community sort of went, "Oh my god!" Because the Mariners weighed about 1.5 tons. This would have allowed 2 spacecraft that would have been bolted together almost of 18 tons, and at the time, a couple of people said, "Hold on a minute, we don't know enough about Mars generally." And that was always the problem, that if you're about planning these great missions, you need to know what you're doing. So there'd been a series of 21 photographs, and it was a good job it didn't go ahead. And in fact, Voyager was famous because it was the first time that Congress said, "Whoa, we're not funding this," because it became too unwieldy and too expensive. And at the time, not enough was known about Mars. So in 1969, Mariner 6 and 7, and they were flybys, better cameras, they pulled back, but still over the southern hemisphere, which turns out that is the ancient surface of Mars, the crater where it's cratered. the moment of excitement there was there were two moments of excitement. One was Mariner 7 flew over the margin between the South Polar Cap and some of this cratered terrain, and an infrared spectrometer that they had looked and made measurements, and it looked like it had discovered methane. Now,
Yeah,
the
that's
methane, that was it. And there were gas, and I've talked to people in the room, and they said that it was gas. It turned out overnight that, again, it was in those days, it was a fairly cumbersome process to try and analyze this data, and they realized they'd kind of shot the bolt too early, as it were. But that was suddenly, it was like, oh, okay. The other thing that happened with Mariner 7, immediately just after it was starting to fly past Mars, it went crazy and they lost it more or less, and they brought it back. A bit like has happened with Juice, in those days, they weren't sure what had happened, and the best explanation was a battery had exploded. So everything that you need to know about space exploration, your hardware goes crazy, and all this stuff happened in those early days. And then after that, there was the first Mars orbiter, which was Mariner 9, and again there were two. There was Mariner 8 and Mariner 9, and they were supposed to be, to act in tandem. So one would find something, and then Mariner 9 would look. So in March of 1969, Mariner 8's launched. There was a problem with the vernier engine in one of the first stage, and it started going screwy and ended up crashing. So it was all down to Mariner 9. And as Mariner 9 was going towards the red planet, ground-based observers saw, which was, I think, certainly in the 20th century, the greatest global Martian dust storm. So it arrived, and Mars was completely featureless.
I remember that one. Yeah, I remember that.
Yeah.
So they just had to wait for the dust to settle. In the meantime, unfortunately, in this book, and I did in the previous one, in 1988, the whole history of the Soviet space program, which again is another, talk in itself. They had lots of bad luck, and in 1971, Mars 2 and Mars 3 were heading there. So it was like the race, who's going to get there first. But their spacecraft couldn't be reprogrammed. They were going to have to land on Mars anyway. And they did in the middle of this murk, and they lost Mars 2, and Mars 3 landed, and there was the first, signs of a picture, which if it had completed would have just shown lots of dust. So it did land and it crashed, which is another, constant feature of Mars exploration. But Mariner 9 went into orbit, and the dust settled, and then suddenly it was like this geological wonderland. And if you can see next to, I'll pick on Andy, next to Andy's head to the left, you see the volcanoes, the three volcanoes.
Yeah.
And then Mariner Valley, and suddenly Mars, it was like, okay. And then that pendulum went back, because suddenly now, okay, there's been geological activity. If you've got geological activity, you've got volcanoes, you've got heat, you've got warmth. There was the discovery of water, or ancient water. So that was then set up the Viking mission in 1976.
So what are your thoughts about the Viking experiments? Because at the time, the results were pretty much dismissed.
Yes.
But I think later reevaluation of the data seems to indicate, well, there may have been something going on. What do you think?
Well, again, purely as a hack who spoke to all these people, again, I was very privileged because most of them are no longer here. So I spoke to all the people who built the instruments and the guys who'd, because Viking was the big pan-technical mission, and it was the one that was going to land. It was America's 200th anniversary, the bicentennial. So, and as soon as Viking got there, there wasn't the dust, its cameras were better. And where they wanted to land, they suddenly realized, again, what looked like plains was actually, rugged surface. So there was a 3-week period where they stayed up, got the latest pictures. And the simpler way you do is you count craters, because that seems to be the logical way to do it. If there's more craters in one area, it's probably going to be rougher. They found this place, the Plain of Gold. It landed on July the 20th. Again, talking to them, they said, well, we thought one would work and the other, and both landed. And Viking 2 was in September.
I'd like to remember the Viking 1 landing.
James
I was actually 15 at the time.
Yeah.
And I always remember watching the pictures coming in on the TV news one night. And the first images that were processed, the first color images were processed with a blue sky.
With the blue sky.
And
Yeah.
then recalibrated.
There's a great story about that, which I'll tell. But
Yeah.
anyway, so its aim was they spent, what it was, $2 billion, and we're going to find life. Now, behind the scenes, there were these instruments that were built, and this isn't just journalistic. This was a person I knew very well was a guy called Jerry Soffen, who was the project scientist for Viking, and he had to basically stop all the warring and fighting, and he was the peacemaker. Originally, there were 4 instruments, and one was dropped because they realized Mars was probably drier than it wouldn't work. At that point, the National Academy of Sciences got in, and it was how science used to be done, with kind of crusty ancient people who, like about our age, who poked their oar in where it wasn't needed because they were the established names. It wasn't a happy ship, and there was all this that was going on. Anyway, July the 31st, 1976, the results came back. So there were 3 instruments. 2 essentially assumed Martian conditions for them to work, and another was it would work anywhere. And the first instrument was called the labeled release. And what it did was took a sample, poured some chicken soup, not actually chicken soup, but a kind of series of nutrients that they thought Martians might eat, Martian microbes might eat, and you measured the amount of because it was slightly radioactive. And as we know, being older, sorry, Rachel, I'll exclude you. We older gentlemen, when we eat, we then give off gas. And that was exactly the principle, that if there were any microbes, that they'd measure the gas. So I talked to 2 people who were standing by the printer when when the data came in, and the data went vroom like that. One of them said, "Oh my God!" And for that sort of overnight, it looked as though, my God, we've discovered life. And the problem with that was it was too great a signal. If there was life, it wouldn't have gone straight up, exponentially. So over the next months, they tried, and it was one of these strange things that happened where the more information they got, the less clear the picture became, because they said, okay, if we run that sample and we run it in darkness, then if there's any photosynthesis, it won't happen because there's no light. But they still got the same signal in one experiment, but not in another. So the whole thing was just, they were trying to make sense of a load of information with very, very, primitive technology by comparison that would take forever for the data to come down. And it didn't make there was no kind of sense. And there became a kind of consensus, that other great thing in science, where everybody got together and said, here's our best guess. And best guess was it wasn't life. Now, Gil Levin, who built the label release experiment, said, that's nonsense. His experiment basically tested positive, and he went, and he lived till a few years ago. He was trying to get another version of that experiment flown, but didn't succeed. And the problem with it was that, there was something in the soil that, to begin with, they actually said at one of the press conferences, it mimics life. And that people then, in some of the press, life's been found, but it wasn't. And then the big kicker to the story was there were no organics. So there was another instrument that measured all the the composition of the stuff that was on the surface, and there was no of those long chain of carbon. Now, if you don't have those long chains of carbon, that you can't explain life, because that's what life is. You have long chains of carbon, and off it goes to amino acids, and then all the base things for DNA and all that stuff. But you need the organics, and there didn't seem to be any. So that was the immediate thing. No bodies, no life. And so after Viking, that was and it was literally like, the day after a party where everybody were, okay. And that was the problem.
Can I just bring Lou in at this point? Lou, have you got any sort of final thoughts about the Viking data? What do you think?
Sure. It's exciting.
Yeah.
So, Gil Levine, he, till the day he died, he said, I found life on Mars.
Yep. So
that was labeled release. There was the gas chromatograph and one other experiment. It's interesting that in one of those cases, as they were testing these instruments on Earth before launch, some of them they dug up soil from the earth and didn't find any life.
No.
So
There was a massive row about a sample from Antarctica.
Yes.
One team said, well, because there's no life there. Yeah, no. That's ridiculous. Everywhere you look on Earth, there's always life. So it wasn't a happy ship, and that's not to say not just me being a hack trying to find a story, but it was there was a lot of bad feeling, which even before the mission left. I mean, that was one of the things. There was like two camps of well, you can't believe that instrument's a load of junk. It didn't stuff.
Well, when you're going to stick your neck out to say something like "I found life outside the Earth," you need to, you need to be certain. So I get it that the scientific community is cautious. However, something they did not account for are the perchlorates in the soil.
Yeah.
And so, as well as GCRs, right, galactic cosmic rays. So it may be that if you go down maybe a meter or two in the soil, you negate all the GCR ionizing radiation. We don't know if there are perchlorates at that depth, and it might be, and there is subsurface aquifers identified from orbit that are fairly shallow water. So this is one location, one set of data. The instruments, I think, were somewhat flawed. The question in my mind is, why the hell haven't we tried it again?
Yeah.
It's been since 1976. What's the deal?
Yeah, exactly.
There's been a mission which you probably know more about than I do, which every so often when there's the sort of annual, we're going to decide on some missions, which one. There was one called the Icebreaker, which should land near the South Pole, I think it was, for exactly what you've said, because colder, there's lots of ice of different forms. You drill a hole, and then you look at exactly what you said. There might be this stuff there that's sort of almost remnants, and it's it's perfect for you to be able to look at. But I don't think it's ever got. I don't think it got funded. And the thing that it's in the book. He said there's a couple of people have realised that there might have been perchlorates in the Viking data, but they burn it. So the stuff was put into the GCMS, as you said, the gas chromatograph spectrometer. Heat it up, and you look at the colours of the spread. And if there were perchlorates in that soil, it would have it'd have burnt them. So it's like before your very eyes, the data might have disappeared. And there've been a couple of people who've been going through. It's like an episode of CSI Mars. They've been going through the data from 1976 to see if this reaction and that, and then if you saw this, that's what you might expect to see. So it could well be, but it's typical of Mars exploration. It's there before your very eyes and it disappears.
Well, my question about that, I have two questions really. The first is that you're absolutely right, Lou. Why hasn't it been tried again? All the missions that go to Mars seem to be looking for the environment where life could have existed rather than the life itself, which seems, it's fine to look for ancient life environments, but why the hell aren't we doing what Viking did, digging down, taking samples and analysing them?
Can I say something else on that as well?
Yeah.
Is it your fault, Michael?
Sorry?
Is it your fault?
No, it's not my fault.
I thought you were going to take responsibility. Okay. Go ahead.
So Michael has to speak up because he's going line dancing later.
Yeah.
Wow.
No, I'm just going to say that the European Rosalind Franklin rover has got a drill that can actually dig up to 2 meters.
Yes, that's true.
So hopefully that will be successful.
One of the criticisms of Viking, by the way, was several people at the time said trying to just go there and look for life to land and dig it up is ridiculous because you don't know enough about the rest of the planet. And at one point in the community, there was it was called the Martian Horror Story, and that was Viking, because you knew there were still so many fundamental things not known that you needed to know those before you could put the life experiments there. So it's the horse and the cart, which do you do first? The Viking was predicated on we'll land, we'll take a sample, and it'll be there. it landed and took the samples, and nothing was found. So it's like, okay, move on. Yeah, let's move to let's do something else. And I think it was, to me, it wasn't so much the it's more like the psychological effect of not finding it at all, that people thought it was the morning after feel. And nobody in 1976 would have thought it would be another 21 years before the next American lander, Pathfinder. And that's what it was. And now it's got and that's another pendulum. Now there's the community of people. You talk to astronomers, and they're moaning about the Mars people because they've got most of the budget, and it's like, no, but you need to keep it to a certain level to build the expertise and have the postdocs and the doctors, the PhD students to be able to look at this stuff. So it's a difficult one, but I think again, so answering your question, Andy, is I think these next missions which are on now probably will, it'll get us nearer to the answer, but I don't know if the answer will be unequivocally yes, it's life, because there are so many things that it could also be that you need to eliminate, and we still don't know. And it could be you dig around and you don't find it. One of the more recent missions to Mars was InSight, which was the American mission would have originally been cancelled. The American one was cancelled, so we had the British and French seismometers. And if you remember, there was the drill that was going to drill down.
The drill that kept coming out again.
Yeah, well, that's it. You see, the point with that was anywhere else we'd landed on Mars, it would have worked. But again, the one place where this landed, it couldn't get enough purchase because nobody, and to this day nobody. When I was a journalist, these were the questions which I always used to say, where people would close the door before they answered, because it was like nobody wanted to say, I'll tell you, but speculate here and all that. So you don't know. So the same with life. It could be we build all these instruments now. We've got these rovers. They're trundling along, and they might, it might just be somewhere else that they've missed. It's
this is precisely why we need people on the ground, isn't it?
Yes.
We need geologists on the ground. That's the answer to everything, isn't it?
Yeah, because I mean, with that drill, I still say it was the little Martians pushing it back up. When they're staying here, so
it looked like it was,
but we didn't realise it because it's underground. But I mean, you were saying, Nick, about the Saturn V. Well, of course, von Braun's main aim was he wanted to go to Mars. He didn't want to go to
absolutely
to
Das
the moon.
Mars project. He wrote this in 1952, and it was a very Germanic, sort of way of getting to Mars. And the problem is this, that so 1988, Mars opposition. For a while, Mars was a kind of taboo within NASA. Nobody could travel to a conference about Mars or do anything. And there was a group of people who call themselves the Mars Underground, Chris McKay, and they're still around, they're around now. And they organised these conferences called Case for Mars, which then built up the kind of scientific, because Chris said to me once, Viking was such a psychological, paraphrasing, such a psychological shock that nobody, they've moved on, and there's lots of great data there that nobody's looked at. So this I went out for Case for Mars 3, the third one, and by then the then NASA administrator, it was James Fletcher, was the first time he'd ever a NASA boss had attended one of these conferences, and we would, we're talking to people about Mars, and I had arrived to stay in a motel each day. I got a cab to the university. It was in Boulder, in Colorado. So just out of curiosity, I'd ask the cabbies, what do you think we should send humans to Mars? And it was about 50% said yes and 50% said no. And more recently, I got the feeling from just following stuff that people now, instead of we should be spending all this money on filling here and wasting money in space and blah, 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 and all that, that now it was suddenly going to be, the public opinion had changed, that maybe, we're kind of pushing towards it and it's a good thing. And then all of a sudden, all the billionaires, the billionaires playground, and now suddenly there's a lot of, anti-billionaire feeling. So I think we're going to have to go there, send humans there. It won't be easy. And I think people are also going to have to get used to the fact that people will die in the attempt, because you can send probes to Mars, but the human body might not survive some of the stuff.
Yeah, absolutely. And if you want to know more about how humans can survive the journey to Mars and living on the surface, there's a video on the channel already about the hazards of living on Mars. So go and have a look at that for more information. Nick, I was going to say that there was a recent poll done among Americans, and for the first time in quite a long time, a significant majority of Americans are now saying they want NASA to go to the Moon and Mars. So this is great news. As public opinion has changed.
Yes.
So maybe they're saying they want NASA to go and not the billionaires. I mean, there may be that behind it.
Yeah.
But it doesn't matter. I mean, if the public are behind going back to the Moon and Mars, I think that's great news for NASA.
Yeah. The other problem that was, again, looked at this, and it was the idea: do you go to the Moon first and you build your long duration habitable whatevers and gain the experience there, and then go to Mars? And in the 80s, when after the Challenger accident, when the American space program was in the doldrums, there was a congressional inquiry, there was a presidential one, and all this, and they all came to slightly different conclusions. Some said Moon first and Mars. And if you remember, which Mike and I do because we're very old, in 1989, George Bush the first said, remember that the Smithsonian and the Apollo 11 crew were there, we're going to return to the Moon, and then we're going to go to Mars. And within 2 years, that all died, mainly because NASA wouldn't tell the administration how much it was going to cost, which was $400 billion. So that's $400 billion in 1989, and that just fell apart. So unless somebody can cut the Gordian knot of the costs, I do think it will be some combination of Elon Musk and maybe somebody else doing it all. The Chinese space program, it will be done, but it's like there's lots of things when I was reporting that were 20 years away. One was a human landing on Mars, nuclear fusion, and the Stones making another great album. Sorry, that's
never going to happen.
No.
Did they ever make
it? But the point is, it's always 20 years away, and then you go to 20 years. And it will happen. Nobody knows when. And the kind of stuff that's now gone on when NASA's budget's been locked, and we don't know when the samples are going to be returned. It's
right. The other thing I was going to say was that when scientists said that the results of the Viking tests, they had something that was mimicking life, and of course that was, you said, reported immediately by the media as, hey, we found life on Mars. They didn't learn their lesson, because a few years later they announced they had a meteorite from Mars that contained life.
My most exciting night as a journalist, which was that. When that
Alan Hills was an Alan Hills
meteorite. And I always thought, whenever I talk about that, there's meteorites, some have come from Mars. And the reason we know they come from Mars because Viking measured the atmospheric composition, and some of these meteorites that are picked up in Antarctica, gas was taken out, and they have exactly the same profile. So we know they've come from Mars. And the Alan Hills one, if you imagine a series of meteorites, I always thought it was the one that would be sitting on the naughty chair, because it was so strange. It wasn't like anything else, and it was people said it's a really weird. And then all that sort of stuff went on. And it was, the team at the Johnson Space Center, they'd been looking at rocks, moon rocks, they'd been looking at meteorites, and they'd never seen anything like this. And if you interpreted it in a way, and at that time there was, if you remember, there was the worm, the thing that looked like a sort of object, and there were crystals of magnetite, which were so pure, nobody's ever been able at that time to produce them in a laboratory. And so, there was lots of circumstantial evidence. If you interpreted it as, Columbo, just one more question, you could say, okay, it's pretty convincing, but there was no, it wasn't an arrest warrant. It was, we'll haul this in as a suspect. And then it went off. And again, like Viking, the more people looked at the meteorite, it now goes to experts on, meteoritical chemistry who all hate. There's something about, I don't know, the expertise in science. The two people who are the world experts always hate each other. And there's always this stuff where, people at conferences, having real barneys about it, purely because if you've spent all your life looking at biological remnants and it looks like that, you're going to say, other people don't say. Now, the key, the thing that's happened recently is in shock explode, where they sort of do a big explosion at a really high temperature. There's this, they can now make magnetite crystals that are as pure that we're seeing in that sample. So instead of making it easier, and it's one of those things, it's like Jarndyce and Jarndyce in Dickens, the court case that went on for generations. The people will still be arguing about this. It doesn't get you any nearer to the question. But again, that was, I was very lucky because I was in a position to report on that at the time, and it was, and it was like, wow, And recently there was an interesting thing, because after that it was decided that any time NASA finds anything like that, it has to go to the White House first. And there was there was something, and I was, again, because I'm old and forgetful, I wasn't covering it properly. I think it was an observation from the Curiosity rover that they'd found something that hinted at, and it could, and if it was interpreted in a certain way, it would suggest that life might have been there. But that they've now got quite, how can we say, more.
This might be the confirmation of work that was done by Mike Muma at Goddard Space Flight Center with the IRCF, where he identified methane in the atmosphere of Mars. And the problem there is that methane is very volatile, and it shouldn't be there because it breaks up almost as soon as it formed. Curiosity also identified that on the surface. And in both cases, they were able to identify annular cycles. Sorry, did I say annular? Annual cycles of this methane. So in the spring and summer, the concentration would increase, and then in the fall and the winter, the concentration would decrease. That would be consistent with microbial life under the surface, but it's also consistent with other non-biological explanations. So in all of these cases, you have both the ALH 8001, the Mars meteorite, the Viking measurements, the surface methane. In all these cases, oh, thank you.
Yeah.
You could explain it either way. So,
so this is what was found in the Martian meteorite that did look like a streptococcus or something like that. Yeah.
The only problem with that was it was about the 10th scale of what you would expect. Right. So the problem is, if that was a worm, how could you get the DNA? And it's because that was one thing that wanted. But it looked like a worm.
That's right.
But just because something looks like something doesn't. The other thing with methane is quite interesting, particularly with Curiosity, because the guy you just mentioned, Goddard,
Mike Muma,
he built so if you saw Curiosity parked next to Perseverance, Curiosity's got this box, the Mars, the thing that Mike Muma built, which is I forget what it's called, SAM?
It's called Sample Analysis at Mars, SAM.
Mars, that's it, yeah. Have I passed my Viva, by the way?
Yes.
Okay. I'm not just making this up. It was called SAM, Sample Analysis at Mars. It's a big box, and the strange thing with methane was with the stuff that they measured at the surface. When Mars is cold, the average temperature is what, -60. So at night they open the thing, let all the Martian air in, take the sample, let it there, and then they take all the CO2 out, and what's left they've looked at, and that's where they found these parts per billion of methane. And there was one of the European craft, the Mars Express, that had a spectrometer that looked down, and there seemed to be that it had seen some concentration maybe of methane. So in 2016, the Trace Gas Orbiter, probably the most boringly named Mars mission, but that its aim was to try and solve the mystery of Martian methane. And guess what? It's made it more complicated because it's not found anything. So at the surface, Curiosity is 12 feet. So you've got something that's there, but the spectrometer looking down and looking down through the atmosphere and looking across hasn't found it. So it's like it's another mystery that the thing that was there that was supposed to solve this riddle hasn't, and that was probably because of the dust storm in 2018 that was, certainly the most.
It could be.
Yeah, but no, I've not.
When you're looking down through the atmosphere, then you're dependent on your radiative transfer modeling of each segment of the atmosphere.
Yeah.
You have all this other stuff going on. The temperature's changing, the pressure's changing, the composition of each layer is changing. The absorption and scattering cross sections are changing. So it may be that at these small levels, parts per billion, as you're saying, Nick, I'd have to look more carefully, but it may be that the sensitivity of the instrument wasn't sufficient.
Or if there's methane and there's lots of dust, does the dust do something? I don't know.
Yes, the dust is a very strong infrared emitter.
Yeah, exactly, and it made
that's where you see the methane lines.
Yeah, so but this to me is what exploration is about. Here we're going to solve this and then launch something, and then it's become more complicated. So to answer the original question, is there life on Mars? I think there's probably is or was, and we will find it. Now, betting man, will it be in the next 10 years, or will it be in
those canisters?
Yeah, so we need those canisters.
We need those canisters. Yeah.
Michael, make it so. Go.
Yeah, and we do have a video coming up this week on Mars Month on the channel, all about the Mars sample return mission and how we're going to get that those priceless samples back from the red planet. So keep your eye out for that. And the best way you can do that is to subscribe to the channel if you're not already, and click the notification bell so that you get notified of when we publish anything on the channel. Right. Well, Nick, it's been an utter joy. I'm sure we could sit and talk for hours. We hope you will come back and tell us.
You're going to have to die in a different life. Yeah.
Yeah. So we hope that you will come back. And,
I'm sure I will. I'll find some excuse. What I wanted to say was, again, so plug. Talk amongst yourselves, and and pick a name out of a hat. If you let me know,
Can you read a chapter now, Nick? Can you read a chapter now?
Hello, children. It's time for bed. I'm going to send you to sleep. Yeah.
Yes.
Thank you very much.
Yes.
And it's great. And I've always said that the people who will get us to Mars aren't, and Lou, forgive me for saying this, Mars is too important to be left to scientists and engineers. It's
ouch.
To be left it's to be left to people who will push for this, because it's, to me, it's the greatest adventure of my lifetime. And will we discover it? Who knows? But let's hope that it happens.
Well, Nick, I mean, we're all children of Apollo.
We are.
We all thought that this would have happened a long time ago, and we want to live to see it. Yeah.
Yeah, exactly.
So we have to push for it. There we are. Nick, the book is called The Search for Life on Mars. Where can one obtain it to buy it?
It should be. It's an American publisher, and so, but it's still around on Waterstones, on Amazon, and bookshop.org, and so it's me, Elizabeth Howell, the co-author, and it's still around. And even though I say it tells you the story up to 2020. Which is the last possible time that you could do a book like that, because there's so much data that's coming now. The next book will have to, and the next thing will be the sample return, and that moment when it's opened. And hopefully somebody watching this might think, if that bloke can write a book like that, then I can. So please do, because I think it's going to be a great, it's a great story.
And thank you for sort of like giving us the history of these events, because I mean, some of the, just listening to the stories of the people who were involved in these events. I mean, the Apollos, the Challengers, the anything to do with any probes or anything like that, like Lou with the Voyager. Just hearing their stories and their story of how things happen, I find intriguing. I really do. I love the history of space.
We've got some thanks for you. Derek says thanks, very interesting. Sandra says thanks, Nick, I really enjoyed that, very interesting. And Stuart says brilliant, enjoyed the talk very much. So
great. And to Stuart, Sandra and Derek, it's okay. you'll get your family back, so you don't have to keep kidnapping us.
There we are. And if you look at what Lou's up to, the search for life on Mars,
There
we
are.
are at
Amazon. It's Amazon.
$6, cheap at half the price.
Cheap at half.
So,
Yeah, they can't get rid of it fast enough.
It's not. I couldn't find it on Amazon UK though.
No. Well,
Amazon US.
Well, try to keep up, guys.
If anybody wants it, they can't find it, just go through Mike. He'll send me an email and we'll figure something out.
Okay.
All right.
I mean,
real fans already have copies. You said.
Oh, here we go.
Poor show, Michael. Poor show.
Just one second, because while we're in the pushing books, just so it's worth pointing out at this point. Just give me a second. I'm off camera for it, but here I am.
A talking bookcase.
Yeah. Okay, look at this. Bernard Hennin, who is a Space Oddities member.
Oh yes.
Most of you probably know Bernard. Time to plug his books. One is called Exploring the Ocean Worlds of Our Solar System, which is a really, really fascinating read. This is the old version. He's just updated it with a new version, given new data, as these things, the way these things tend to go. So that's Bernard Hennin, Exploring the Ocean Worlds of Our Solar System. He's also written a really interesting book called Imaging Our Solar System, which is about the history of spacecraft imaging. And you'd think that was a very dry technical subject, but believe me, it's an absolutely fascinating read.
Yeah.
So Bernard, some love too while we're plugging books.
Yep.
And they're available on Amazon too. So and both at Amazon UK, I think. So there we are. Nick, you are more than welcome to hang around and join in the rest of the festivities this evening.
Oh, well, I just noticed behind you, you've got a black cat with a curly tail. I just need to go downstairs to see my black cat with a curly tail, and then I'll come back. That's okay. I might even bring him. We'll see.
Okay, yeah, do. Come and introduce.
Yeah. So talk amongst yourselves, and I'm going to go and find.
See you in a bit.
Both of my cats are asleep on the bed. No.
Bring my cat to work, is it? Bring my cat to work.
There are another two to come because I normally have 3 sleeping on my bed. We've recently got a new dog.
Yes.
That is a cross between a Labrador and we don't know, but it could be a Doberman by the look of it. So it means it's going to be an enormous dog. And we've got one cat who was completely unfazed by it, and within 10 minutes was eating side by side with the dog. The other 3 are petrified, but I'm sure they'll come round. But yeah, cats are strange like that. The one that loves the dog is very strange. Cat Oddities, absolutely.
Hey.
Cat Oddities. We'll bear that in mind, Rachel. So thank you very much.
There's going to be people logging on thinking, what is happening?
What's going on? I'll tell you what's happening. It's time to go to Roger's place through the round window.
Is it really?
So
Very quiet.
So anyway, Roger, can we hear you? No, you've already gone again. Oh dear.
Let's all chip in a little for Roger. Get him a little.
That's what happens when you buy a headset from Temu. He speaks in Chinese.
Yeah, it's a translator.
Say something, Roger.
Say something.
Are you there, Roger?
No. Okay, well, listen, we'll let Roger get himself out. Let me just.
That's Roger.
So
let's bring the cats back.
Yes,
So
they're still downstairs.
Roger's had to leave us because he's got headset problems. So
Roger's got a 20-minute delay.
Yeah. Oh, hang on, he's back already. You just can't get rid of him, can you? Hang on 1 second. Right, let's do Roger back. Right, say something, Roger.
Something, Roger.
Hey!
Roger that.
Okay, so hang on, Roger. I'll just give you the wherewithal to do your thing.
Oh no, I got to upload my presentation now.
Oh,
So
okay.
I'll load it again, yeah.
Ah.
Well, while Roger's doing that, something that's been, we're talking about Mars and things like that. And of course, we're looking towards the future. We're talking about colonizing. And you always get where they're going to sort of like, they're going to completely change the atmosphere of Mars and things like that. So people will be able to live without suits and things like that.
I don't believe that.
Sorry, sorry, Michael.
I don't agree with that.
Well, the thing is, what my thinking is okay, you should be able to do that, but surely it would have to be within a dome, because at the end of the day, Mars doesn't have a sort of like a very strong magnetosphere like we've got. So
No.
how would you stop any, if you're terraforming, any atmosphere you do create from being stripped away again, which is what
Yeah.
they originally happened with Mars, because it's got it hasn't got it hasn't got a molten core, which is what gives us, with the solid core and the rotation of the Earth, gives us our magnetism. How would you be able to capture and keep the atmosphere if you don't have a magnetosphere to protect it from the solar winds, which is something that you don't really hear anything about? So when they sort of talk about terraform, I always take that with a massive pinch of salt. Anyone got any ideas or something?
Well, I think it's not so much the lack of a global magnetic field on Mars. It's Mars gravity that is completely unable to hang on to any atmosphere that you might generate. I think that's probably
that's part of it. For any planetary atmosphere, you have three things that determine the escape rate of gases. One is gravity, one is the mass of the particle, and the other is temperature. So gravity, Mars, not much. Temperature doesn't win there. And then if you're maybe just water you're interested in, you just hit it with UV and the hydrogen goes away, and then you're left with oxygen, which probably produces CO2. But the other thing you can do is you can replace it at a rate similar to the erosion rate. And my understanding from the MAVEN spacecraft, which was sent to do one thing and one thing only, and that was to identify the erosion processes in the atmosphere of Mars. Mars is losing about a quarter of a pound. Sorry to use these units. About a quarter of a pound of atmosphere per second. So whatever that is, if you can replenish the atmosphere at that rate, it seems like you'd be okay.
Yeah, because I mean the MOXIE did on Perseverance did actually produce quite a large amount of oxygen for the rate, far more than they thought they were actually going to get. But I like I said, I'm still, this business about. I mean, Paul's just said the same as what I'm thinking. Doesn't account for solar wind stripping of the atmosphere.
Yeah, thanks, Paul.
I mean, I don't know. I mean, maybe something. It's one of these things we don't know until we try it.
Yeah. By the way, there's a nasty buzz on the sound. Can everybody else hear that?
Yes.
I can.
Yeah. Apologies, viewers. We don't know where that's coming from.
Let's go.
Stopped. Okay, right. So anyway, moving on. Roger, are you ready, willing, and able?
I'm just trying to upload it a second time. It failed on the first attempt.
Okay,
You
what
should
we're
be
going to do then?
momentarily available.
Oh, right. Is that the American momentarily or the British momentarily?
Oh well,
Hey.
that is the question.
No, it's a valid point, Lou. It's a valid point. They have completely different meanings. So there we are.
Like a country mile or a standard mile.
Our momentarily is it's going to be 20 years till we get to Mars. So.
Yeah.
Yeah. Absolutely. Right. How's it going, Roger? Because if not, we'll go on to something else. No.
I'm
okay.
still.
We'll just mess things up.
Move on, and then I'll should be okay after that.
We'll come back to you. What we're going to do now is to really kick off Mars Month. I thought that there may be some of you out there, not many, I'm sure, who might not be that familiar with the basics of what Mars is all about. So to that end, we're going to have a look at the basics of Mars. Call it a Mars 101, if you like, the basics of the planet Mars. So here we are, and this is just the very basics about Mars. So what do we know about Mars? Well, obviously it's a planet. It's the fourth from the sun. It's often called the red planet due to iron oxide, or rust if you prefer, on its surface, giving it a reddish appearance. It's named after the Roman god of war, and there may be an association there with the planet, with the color red, of course, because Mars is distinctly red in the night sky. And of course, red is traditionally associated with war. So that may be why they named it after the god of war. But who knows? It was a long time ago. So size and distance. Well, Mars is it's got a radius of just over 2,000 miles. It makes it about half the size of the Earth. Its orbital characteristics. It orbits the sun at an average distance of 142 million miles, which means Mars is about 1.5 times further from the sun than the Earth is. Sunlight takes about 13 minutes to get to Mars. Compare that with about 8 minutes for the Earth. Now, the Martian day is called a sol, that's S-O-L, and it lasts 24.6 hours. So it's very close indeed to the length of a day on Earth. On the other hand, the Martian year is 687 Earth days. It's almost twice as long as Earth's year. Mars does have seasons, but there's a difference between the two planets. Whereas Earth has an axial tilt of 23.5 degrees, Mars has a 25-degree axial tilt. So what this means is that the seasons actually last longer, and they vary in length also because of Mars' elliptical orbit. So slightly different setup with the seasons on Mars. Lots of famous landscape features on Mars, the most famous of which we talked about earlier. We mentioned earlier Olympus Mons, the tallest volcano in the solar system, about 13 miles high, which makes it nearly 3 times the height of Everest. In terms of surface area, Olympus Mons isn't far off the size of France. So it's an absolutely monstrous volcano on the surface of Mars, tallest one in the solar system. The other famous feature, of course, Valles Marineris, the longest canyon in the solar system. It's about just under 2,500 miles long. It's about the width of the continental United States, and it digs down up to 4 miles. So it's a massive rip in the crust of Mars. The two hemispheres, northern and southern, are quite different. The northern hemispheres characterized by low-lying plains with smoother and younger terrain, possibly shaped by ancient oceans. The southern hemisphere is characterized by ancient, heavily cratered highlands with rugged and older geological features. In terms of climate and temperature, well, Mars is a cold desert world. No water has flowed on its surface for billions of years. Average temperature, as Nick said earlier, about minus 60 degrees Celsius. But there is a surprising amount of variation. If you're at the equator on Mars on Midsummer Day, the temperature can go up to 20 degrees Celsius. On the other hand, it goes down to minus 153 at the poles. So you've got this big variation in temperature. Of course, this very thin atmosphere also means that Mars can't retain any heat. So if you imagine what it's like being in the desert on the Earth when it's very hot during the day, but it gets very cold at night. Well, it's like that on Mars, but a hell of a lot worse because it goes way down below zero at night. In terms of atmosphere and gravity, well, as you probably know, Mars has a 95% carbon dioxide atmosphere, less than 1% oxygen, so definitely not breathable by humans. It's got less than 1% of the atmospheric pressure of the Earth. So what this means is no liquid water, basically. And it only has 38% of Earth's gravity. So obviously, if you weighed 100 pounds on the Earth, you'd weigh only 38 pounds on Mars. The two moons on Mars, as you probably know, Phobos. This is the larger moon, 22 kilometers across. It orbits closer to Mars. Its fate is a little messy, I'm afraid. It is gradually falling out of orbit towards Mars, and it's expected to crash into the surface of Mars in approximately 50 million years. So, make a note of that in your diary. That may well generate a small ring around Mars, due to the impact, but we won't be there to see it, obviously. The smaller of the two moons is Deimos, 12 kilometers diameter. We've never had a close look at Deimos. All of the images from Deimos have been taken at quite a distance, but it does look very different to Phobos. As you can see in this image, Phobos is characterized by craters, including the huge crater at the end there, and these rather strange scratches across its surface. Deimos appears to be much more covered in dust and with far fewer craters. Whatever their appearance, the origin of both of these moons is that they are probably captured asteroids that were captured billions of years ago by Mars gravity. Obviously, they're not spherical, they're potato-shaped. So they are nothing like our own moon. In terms of water, well, we know from everything we've been talking about this evening, the Viking missions, Perseverance, Mariner, Curiosity, all of these missions have revealed a Mars that almost certainly had water flowing across its surface billions of years ago when the climate was much, much warmer. And the features that we see from that, ancient riverbeds, water-formed minerals, delta formations, which Perseverance has actually been examining a delta on Mars. Lots of interesting data there. And so there's absolutely no doubt that Mars had a warm, wet past. Exactly when that happened and how long it lasted is still open for debate. But we are looking at a world that lost its atmosphere. The core froze, geological activity more or less stopped. There was never any tectonic activity on Mars. We don't think Mars ever had plate tectonics, but it certainly had lots of volcanoes, including the previously mentioned Olympus Mons. So there is lots of water on Mars, but it's all underground as water ice because water cannot exist on the surface. Plus, of course, you've got it on the surface in the form of ice at the two poles of Mars, the two polar caps, which are visible even in small telescopes. Why does Mars matter? Well, it matters for lots of reasons. It's a key target for exploration to understand planetary evolution and the possibility of past microbial life. Robotic missions like Perseverance and Curiosity are paving the way for what we've been talking about, future human exploration, although when that's going to happen, we don't know. Studying the red planet, as studying all the planets in the solar system, help us learn about Earth's past and future and the potential for life beyond our world. This is incredibly important to study Mars in particular, because it's the only real planet in the solar system where we can attempt to make a foothold and survive on. And I would just leave you with a quote from Buzz Aldrin, and he simply said, Mars is there waiting to be reached. So let's go, basically. So there you are. So I hope that you learned a few things from that, the very basics of Mars. Hopefully now we can go over to Deepest Sparkford, and we're getting a thumbs up. I can hear my earpiece. Yes, he's ready. Yes, he's ready. Can you please give us the votes from the Swedish jury? Oh, sorry, wrong show.
Nil point.
No point. Thank you very much. Okay, so what's in the night sky, Roger? Let's hit it.
Well, we got quite a bit on tonight. We've got the weekly guide. We've also got a spoiler alert, total lunar eclipse on Sunday, which I'll delve into. Plus, we've got a massive gallery again. Thank you all for your images. So, let's try and get it done before the 10 o'clock deadline.
Otherwise, we'll be in trouble with Derek.
We'll be in deep doo-doos. Right. Okay, so here we go. So the 2nd to the 7th of September. So we're going to be meeting up with different things in the night sky through this coming week. Starting with working our way up through to a full moon on Sunday, which is when we've got the lunar eclipse. More on that shortly. But through the week, we've still got the glorious summer triangle overhead, with Saturn coming up nicely for observations, if you so wish, all coming along nicely. And as you can see, trailing up from the northeast, we've got the winter constellation starting to appear. Ooh. But before that happens in the morning, we've still got Jupiter, Venus, and Mercury coming up through just before dawn. So Jupiter will obviously be the first one to see, and then we've got a lovely bright Venus. Mercury might be a bit of a challenge due to its low altitude before the sun gradually blots out poor little Mercury, but there we go. So we've got some Auriga meteors which are happening at the moment. Not one of the most popular ones, but we can see some if we're looking for them. Only about 5 an hour, which is hardly anything. But there we go. We can always try and spot something, but there's usually something up in the night sky which we can usually recognize as a meteor. So it might be one of these. So we can obviously, hopefully, get to see what we can see through the cameras. So we're looking 30 to 40 degrees away from Auriga to get the best possibility chance, and any time after midnight to try and have a look towards the eastern horizon to see if we do see any glaring little mites shining away there. So we've got a few different planets coming up through. We've obviously got Saturn, which is becoming more dominant in the night sky. So that's all well and good. We are starting to get a bit of a tilt. We've got now over 3 degrees of tilt there. So we are starting to see the rings, although the Cassini division is still a little bit of a challenge. But nevertheless, it is still there. So we've got rising up about 9 o'clock. So it's starting to become visible just after it gets dark. Now that we are getting some proper astronomical darkness, so it's making its way through. Although Neptune is magnitude 7.8, so we do need a little bit more to be precisely looking towards where it is. So it is a bit more of a challenge, but as we get through the week, we do get them coming quite close together. And on the 7th of September, they are 9 degrees apart between the full moon and Saturn, so that could be a little photo opportunity. And on the 8th, the following day, we've got Moon, Jupiter, and Neptune, although Neptune will be a bit of a challenge, so that will have to be a carefully prepared viewing for that, but it's an opportunity. So this is how it's going to be. This is from Stellarium, so Neptune sort of in between the two other objects. So if you do want to try and find it, there is an opportunity there to be able to try and get to see the little blue dot there. So we've got a transit on the 3rd and the 4th. So later on in the week, we will get a transit, which is one of the benefits of having the rings of Saturn at a low angle to be able to see these transits. So an opportunity to capture an event like that. Right, now the big event from the week is Sunday, where we do get a total eclipse, or the blood moon. Now, we will have to be aware that when it does start to rise, it will already be in its full eclipse mode. So unfortunately, we won't see the start of it, but it will be available to see as soon as it starts to rise, and we'll be able to see the rest of the eclipse as it happens through the rest of the rising of the moon. This gives you an idea of where the totality is, and we're on the periphery there. So unfortunately, we will get to see some of it. So let's just hope we've got some clear skies to be able to watch this happen. So fortunately for Africa, Russia, and all those other continents over to the east, they do get the benefits of it. So it's quite interesting to see. And it's quite 82 minutes from start to finish, which is quite a good amount. It's one of the longest amounts of time that we've actually managed to get. So take advantage of that. So we're just behind the science of the red colour. So it's a process of what they call the Rayleigh scattering, which is blowing through the atmosphere, through the Earth's atmosphere, and also shining it through onto the surface of the moon, or the shadow. So I'm sure most of you were able to understand all the basic principles of that. So Australia, Asia, Africa, and Europe will be able to get most of the benefit. So Western North America will see the beginning stages as the moon sets, and then we'll catch it as it rises over us. So we will be able to see it. Unfortunately, the rest of America won't be able to see it. So for them. So at roughly 3:30, we get the penumbral eclipse starting, and then about another hour after that, the eclipse actually starts. Totality starts at 5:30, and the peak of the maximum eclipse starts at 11 minutes past 6, and 42 minutes later, the totality ends. So by the time it gets to 5 to 8, we end the partial eclipse. But we still got the penumbral eclipse, which carries on for another hour. So between 3:30 and 5 to 8, that gives you the whole time from start to finish. So it's not a bad amount of time. It just depends on what part of the Earth you can actually see it. But hopefully we might get to see it come up as a very vibrant red moon coming up through. I know we usually see it as a sort of an orangey color, but this will be quite a much more deeply colored coloring on because of the eclipse. So the eclipse occurs approximately 2.7 days before the moon reaches perigee, when it's closest to the Earth. So it's partly, we won't call it a supermoon because it's only 3% bigger than when it is at apogee. So I'm sure the news people will be interested to say, it's going to be a larger moon. So you won't notice it. You hardly notice the difference between it's a supermoon and a micromoon, really. But they do like to make a drama out of something. So we're just hoping that we can actually get to see the damn thing without the clouds in the way. So the September full moon is normally called a corn moon. These are obviously the Native American designations that we seem to adopt. But the blood moon is obviously because of the shadow effects from the Earth's atmosphere shining through and reflecting onto the surface. So that's what we'll be calling it, and it's quite an interesting sight to see when you do see it that color. It is a bit of a scary experience if you've not really seen one before. So we give it a total eclipse time span of 5.5 hours. So people will be able to, I'm sure, be posting on social media the start, the middle, and the end. So it'll be quite an interesting event to be actually covering. So if you can't see a solar eclipse, a lunar eclipse is almost the next best thing. So it should be quite good.
Yeah.
But Saturn will also be visible quite near to it. So it'll be quite an interesting comparison to see how much that totality will darken the sky down to be able to see some of the nighttime sky objects back again without all that glare. So we obviously need to make sure that we can have a good clear eastern horizon and try and be able to keep it all into view. So make a note of when it starts to become visible. So it'll be round about 5:30 or so. So just be able to keep an eye out for it. So I'm sure there'll be a lot of newspaper. This is quite an interesting picture. I think I don't know what's happened with this illustration. Looks like Saturn has flung its rings off into the space. It's a bit random. Good old AI. Yeah, something's happened there. It's a bit random. So yeah, but moving on to some other events that we've had. You've obviously got Mars, which can be quite interesting to be able to look for, although it is getting quite low to the sunset. So it could be an interesting experience, especially when it gets near to the location of where Mars is. So maybe have a look for an object to be able to get that connected up to. So we've got Jupiter and the waning moon, and that will be on the 16th of September, so a little bit away, but it's always interesting to compare the planets with the moon if you're into that sort of thing. So that'll be in another alert. So we've also got more spoiler alert. So we've got a partial solar eclipse, but unfortunately we're in the wrong hemisphere. So that'll be in the southern hemisphere for South Africa, Antarctica, and parts of the Indian Ocean. So good luck for them.
So any penguins watching, make note.
Yeah.
Yeah. So they'll be able to have a look at that, and maybe some of the other comets which will start to become available to them as well. So that could be quite an interesting thing.
That's just as a point of fact, there are no penguins in Antarctica. They're all in the atmosphere of Venus.
Oh, okay. Then they come here for vacations, do they?
Yes.
Well, maybe, possibly. Yeah.
So we just need to have a look for any meteors that might be visible. We've got the blood moon eclipse on the 7th, and then we've got some planetary alignments following on. But in the next day or so, we've got a Titan transit coming up through. So have a look for that. So there we go. Right. Okay. Now we're on to the gallery.
Fantastic.
And we've got another amazing quality images. We've got some from Lou here. So he manages to take this with his Galaxy S25 of a crescent moon. And this is what...
Oh, that's lovely.
Yeah.
That's beautiful. That's lovely.
These camera phones are doing us all a favour, I think.
And you can just see the old moon in the new moon's arms there.
Exactly. Yeah. Yeah.
A wee bit of earth shine onto it too.
Yeah, that's lovely.
Definitely.
Right. And then he got his sea star out to do some imaging of the sun. But he did have a little bit of an episode, so he needed to update his firmware and then get his GPS to work away from tall buildings. So once he got that all sussed, he manages to get all of this.
Hey.
Wow.
A nice spotty sun.
Yeah,
Well done, Lou.
That's beautiful.
And of course, all that happened while 35 undergraduates are standing outside waiting to see the sun. So
yeah, no pressure.
Isn't it always the way?
It is.
But there you are. It made up for it with the amount of spots that you've got on there. And then he got another picture with a Coronado 70mm and a ASI camera. And this is what he managed to do with that.
Oh,
wow.
nice.
Oh, wow.
And he's got a nice solar flare there, as well as all the filaments and things on the go.
To catch a white flare is very rare. But you've got some lovely filaments there, as you said, and some nice sunspots and active regions. That's very good. Well, lovely, Lou.
Lovely. Well done.
Thank you.
Yeah. And we've also got a solar image from Michael Murphy, which he got on the 27th of August. We do get quite a few from them. Hey?
That's
more
beautiful
spots. Yeah. So it's all
well done, Michael. That's great.
All getting a reasonable amount of sunspots at the moment.
Yeah.
Right. Now we've got a collection from Carl, and he's got NGC 7331 and Stevens Quintet in this one. With a 4-inch Skywatcher refractor, and this is what he's managed to get.
Wow! Look at that!
Wow!
And then you've got the quintet down the bottom, but you've got galaxies absolutely everywhere.
Yeah, absolutely smothered, isn't it? The whole everywhere you look, you can see.
That's for a fairly small refractor. That's quite amazing.
Yeah, and with the quintet, you can actually see them there, can't you?
Oh yeah.
Don't worry. There's more to come. There's some closer views. So we've got so we've got some croppings of this image. So we've got this one in part. Which was
man!
So,
wow! Carl, that is tremendous.
Look at those dust lanes.
That is
That's fantastic.
Yeah, I mean, you've got those irregular galaxies. You've got a spiral one there.
Yeah.
So well done. And then we've got the Stevens Quintet crop. So we've also got that one. So here we go. You can see all the interactions there with the trailing gas
star bridges and that. Yes, all the interactions, star bridges. That's lovely.
Well done.
Yeah.
And then we've got the supernova in one of the galaxies. So this was a close-up view, but the supernova is at the 1 o'clock position from the central core.
Oh wow!
Okay, that's lovely.
Oh, okay.
That's a bright
So it gives you.
isn't it?
Well, they usually do outshine a lot, don't they? In its entire galaxy.
Yeah.
So there we go. And we've got another one from Carl of the Monkey Head Nebula. So we've got a nice color image of the monkey head here.
Now this is the orientation where you can definitely see the monkey head.
Yes.
You can recognize the actual name from where it gets it from.
Yeah.
That's beautiful. Beautiful color.
Yes.
Lovely.
Yes. We're getting through them. Yes. And I think this might be the last one from Carl. And this is M81, the Bode's Galaxy. He didn't actually label it, but I recognised it. That's what it should be.
Let's hope it is.
Cool. That's lovely.
Very good.
Yes. So
That's
very nice.
Very twirly arms there. With some nice stars there.
9 hours of integration.
Well, that's hardly anything for Tom, isn't it? You know.
No, it's nothing. Tom's
and yeah, I mean, he does like anything between 20 to 30 plus hours.
Yeah.
So there we go.
He's been integrating since he was born.
Yeah, absolutely. So this was Sunday's image that I took of the moon, just for a change, and this gives you some idea of.
Nice one, Roger.
Yeah.
I sort of went a bit. I went a bit dramatic on the processing of this, just to highlight all the details, especially around Mare Crisium there.
Yeah.
You can see some of the mountains and stuff there.
Yeah, the Alpine Mountains, isn't it? Lovely.
Yeah.
And ejecta.
Yeah.
Look at those lines of ejecta.
Oh yeah.
2 places, 3 places.
Yeah. Okay.
Superb.
And I tried to have a go at the Bubble Nebula. So this was my little attempt.
Oh,
that's nice.
well, that worked.
Definitely got the bubble.
Yeah.
Definitely got a bubble.
What is this, 50 hours of integration?
About 10 hours. Hardly anything. I mean, that would be about 1 filter for Tom.
Yeah.
It took you that long to download it from the Hubble archives?
Yeah, something like that. So, yeah.
That's beautiful.
Yeah, that is well done. Bob. Beautiful.
Yeah, so
have you
there we are with the I have done, but it was a wider field where it was integrated with the other nebulas in the area. So I just focused on that because it seemed to be quite a good target just for itself.
Yeah, definitely.
Don't put the Bubble Nebula in the corner, so to speak. And that's what we have for this week.
Hey.
And it's not 10 o'clock yet.
Hey.
Oh, indeed. There is still time. There is still time.
Very nice, Roger.
Okay.
So thank you very much for that, Roger. Fantastic.
Okay. Right.
Thank you all for your submissions. And don't forget, if you would like to send your space images to Space Oddities for inclusion in the gallery here on a Tuesday and in your own gallery on the Space Oddities website, then please attach them to an email. 1 image per email, please, if you would be so kind.
Yes.
And
1.
And mail them to gallery@spaceoddities.space. That's galleries at
I did have one from Lou of the Ring Nebula, but it was a bit of a late entry, so I'm keeping that back for next week.
And it was rubbish.
The suspense is killing me. So yes.
And it was rubbish.
Absolutely.
So
I didn't say that.
It was actually the only the only picture we've ever rejected from the gallery. So
no, we haven't.
No.
Something to shoot for. Something to shoot for.
That's right. Okay, so to finish off this evening, because time's getting on, we're not going to bring you Constellation of the Week this week because we don't want to suffer Derek's wrath for finishing after the allotted time. He's our official timekeeper. I know he's there with his stopwatch and
an egg timer.
An egg timer, yeah. We don't want to get a sundial, so we don't want to get on Derek's bad side. So we're going to give you Constellation of the Week next week. We're going to finish off tonight with our normal, nearly normal, deep dive into the nether regions of social media to see what people are saying about the universe. So here's Einstein of the Week. I have to apologize. It's been a very quiet week for lunatics. So there's only one this week, but it's one that I appreciate. So, ladies and gentlemen, I give you Einstein of the Week. And let's have a look at what we've got. Just the one. So Einstein of the Week this week. Lovely photograph taken of the bottom of the SpaceX Super Heavy booster with its 33 Raptor engines. Lovely photograph taken not long before last week's successful test flight 10. Does anybody want to guess how many joules of useful energy those engines create?
No.
No.
10 to the 30th.
10 to the 30th. Right.
There's my guess.
In advance on 10/30th, 10/30th. No. It's actually 5 times 10 to the 12 joules, which is a hell of a lot of useful energy that's actually providing propulsion. Somebody on social media decided it might have been a little bit more because they said probably has the power of the sun.
Okay.
Oh, very good.
Yeah, absolutely. So that did make me laugh. But,
yeah, I mean, they're probably talking solar power, aren't they?
Yeah.
So,
Yeah.
You just need a few more panels and it'll lift off.
Yeah.
So anyway, I'm afraid that's, as I said, that's all I've got for you.
He even got one like on it too.
Yeah, I know.
That was Andy.
No, I can assure you that wasn't me. So anyway, I'm sure within the next week there'll be more examples of social media total wackiness and lunacy.
Yeah.
So there we are. So that's Einstein of the Week for this week, folks. More next week, I hope. So there we are. All right then. So I think that's about it. We're going to draw things to a close for this evening. I'd like to thank Nick for coming along this evening and giving us such interesting information.
Yes.
Thank you, Nick.
My pleasure. It's always a good joy to talk to you, all of you.
Yeah.
Well, likewise. And you've got the link. It never changes. So anytime you feel like dropping in on Tuesday, if you've got absolutely nothing better to do, then you are more than welcome to come along and join us anytime.
Yeah, that's the best sales pitch I've ever heard. But there we go.
Yeah, there's no money.
There's no money.
Yeah. So message here from Paul says, thank you, lady and gentlemen. It's always great fun to watch Space Oddities. Watching from now.
Raleigh.
You'll know, Lou, in England it's pronounced Rayleigh, but I assume in the States it's pronounced Raleigh. Is that correct?
Oh yeah, you guys mispronounce everything.
like aluminium.
Yeah.
Aluminum.
And momentarily,
we can't get the hang of this American language.
But
or Worcestershire sauce.
Yeah, absolutely. Yeah.
I have a lot of relatives, ancestors from Raleigh.
Oh, really?
So I have a lot of North Carolina roots.
Yeah, it's inconsistent, though, Lou, because we refer to the famous explorer as Sir Walter Raleigh, not Sir Walter Raleigh. So,
yes.
So Raleigh is actually a town in Essex, in case you're interested.
Yes.
So there we are. Sandra says, Derek says, great show as usual, interesting talks with good fun. Good night, folks, and good night to you, Derek. And I think we've kept on his good side, so that's fantastic. Sandra says, thanks everyone, it's been great as always. Thank you. Carl says, great watch. Thank you, Carl. Much appreciated. And Rachel says that she's been calling
Toaster.
Toaster. Thank you. Toaster. Yes.
I'm always, I'm like on the phone, I'm saying to my dad, oh, we're just past her. Is it Toaster Services?
Yes.
And my dad's like, you mean toaster? Like, no.
Yeah, toaster.
Yeah. Like for your bread.
But what Worcester is actually Worcester.
I mean, toaster is next to Silverstone, isn't it? So
yeah.
You don't want to go to Towcester.
It just doesn't look anything like how you'd say toaster, though. It really doesn't.
Well, toaster is Toaster,
yeah,
isn't it?
And I've got one in the kitchen.
Yeah, absolutely.
Or Gloucester.
Yeah, Worcester.
I've got a toaster in the kitchen.
Derek says we've still got 5 minutes. Well, anyway, the idea is to come on under the 2 hours, Derek. Yes. So there we are.
Nice.
So not far off. Give us a break. All right. So we'll be back next week with more stuff about Mars. In the meantime, don't forget to keep your eye on the channel. As I said, every evening this week we will be publishing a new video about Mars, and we'll be doing the same next week, although I don't know if we'll be posting one every night next week, but we'll be posting more videos on the channel throughout the month of September, and our live streams will be all about Mars. We'll be having a Mars quiz towards the end of the month as well, so you've got that to look forward to. Quiz all about Mars. We haven't had a quiz for a long time, so we thought you, our gentle viewers, would appreciate a quiz. So brush up on your Mars knowledge for the great Mars quiz later in the month. We'll let you know.
What, the person who wins the quiz gets the book. How about that?
Wow!
Oh, thank you.
Wow.
And you notice I'm
Wow.
not coming on board because I know I'd come bottom of the class. So there, you know.
Right. Well, there you are. That's your challenge, viewers. Is take place in the Mars quiz and win a copy of Nick's book. That's very kind of you, Nick. And we also ask you to sign it as well.
Yes, and you can get Elizabeth's signature by proxy as well. It'll be signed. Just let me know, and good luck to whoever.
There you are.
Thank you
Nick's
very much.
wonderful book, The Search for Life on Mars, will go to the winner of our Mars quiz later in the month. That will probably be the 3rd Tuesday of September, although we will, of course, keep you posted on that. One way
watch the videos and make notes.
Yeah, absolutely. One way you can keep absolutely bang up to date with what we're up to, of course, is to join our Patreon page, which is patreon.com/Space Oddities. And everything that we're doing is posted well in advance there. You can join in the chat, and there we are. It'll only cost you a few quid each month. So what more do you want? We are posting all the Mars videos a week in advance for Patreon members. This week's videos are already there. Full instructions on how to download them are in the on the Patreon page. There's a chat there called For New Members. So if you join Patreon, have a look at that chat. Full instructions are there where you can get all our Space Oddities downloads. So thank you very much for being here. Stuart says, great show once again. Much appreciated, Stuart. If you could just do us the favor, after the show has ended, if you could just go and put some comments in the comment section on YouTube, because the YouTube algorithm does look at how many comments our videos get. And if we don't get many, it doesn't recommend us to many people. It's all to do with the algorithm, pleasing the algorithm. So if you could just leave a comment after the end of the show on the YouTube video, and like it as well, and share it with everybody in your contacts, in the phone that you might have tucked away somewhere, that would be fantastic as well. So again, great, many thanks to Nick. Thanks for being here, Nick. Thanks for spending your time with us. Come back and again anytime you like.
Sure.
All of Space Oddities. Until next week, for more Mars fun and frolics, we will bid you a very good evening. So from all of us.